For Unit 7, we're going to be looking at what are called rational expressions. And today we're specifically going to be reducing or simplifying rational expressions. So, kind of a quick definition of this, irrational expressions are just expressions that can be written as the quotient of polynomials. So, here's some examples here. Basically, another way to say a rational expression is just something written as a fraction. So we have a trinomial on top, trinomial on bottom. We have a fraction, fraction here, fraction here, fraction here. All of these are rational expressions. So throughout this unit, we're going to be doing a lot with these. We're going to be simplifying them, adding them, subtracting them, multiplying them, dividing them, solving equations with them. But kind of the most basic thing we need to know how to do first is how to simplify these. So before we start, just a couple things about rational expressions. Hopefully we know that we cannot have 0 in our denominator. If we have 0 in our denominator, that is undefined. If you try to type that in your calculator, it's going to give you an error message because it's undefined. We can't divide by 0. So really quick, when we are working with rational expressions, we have to make sure that we cannot have 0 in the denominator. So sometimes there are restricted values. Sometimes there are values that we cannot have for our x, or else our expression is going to be undefined. So like on example 326, it gives us this rational expression, and it asks us to state the excluded values, what values this cannot be, what x cannot be, because if x is that number, we're going to have an undefined expression. So one way we can think about this is saying, okay, we know our denominator cannot equal 0. So let's come over here and see what values give us 0 for our denominator. So I'm going to say, all right, 3x squared plus 5x equals 0. We want to know where this is true, when our denominator equals 0. Well, we have a quadratic, so we can factor this. We can take out an x, and we've got 3x plus 5. All right, if we take each of our factors and set them equal to 0 and solve, we're going to get x equals 0 and x equals negative 5/3. We get that by subtracting 5 and then dividing by 3. So these are our two values that x cannot be. When x equals 0 or when x equals negative 5/3, we're going to have 0 in our denominator. We can't have that. So 0 and negative 5/3 are our excluded values. Okay, one other thing we can do with rational expressions, just with any expression, is we can evaluate it. So here we have this rational expression. We have a binomial on top, a trinomial on bottom, and it asks us to evaluate when our x is negative 6. So to do this, we're going to take negative 6 and substitute it for all of our x's here. So don't forget when we substitute, we put it inside parentheses. So I'm going to have negative 6 squared minus 4 divided by negative 6 squared plus 6 times negative 6 plus 8. All right, from here we could type this in our calculator. We could keep working it by hand. Negative 6 squared is 36. On bottom, we're going to have 36 minus 36 plus 8. 36 minus 4 is 32. That gives me 0. 32 divided by 8 is positive 4. So just a couple things we can do with rational expressions besides just simplifying them. We could find our excluded values. We could evaluate if we know what the value of x is. And then for the rest of the lesson today, we're going to be simplifying. So let's kind of take it back really quick. I'm just going to write an extra problem right here. If we're just simplifying fractions, like if I give you, I don't know, 10 twelfths, and I ask you to simplify this. Well, we could just type this in our calculator, 10 divided by 12, math, enter, enter. It'll simplify it for us. But let's think about what we're really doing, kind of the math behind what your calculator is doing. Your calculator is dividing out the greatest common factor. So I could rewrite 10 as 2 times 5. I could rewrite 12 as 2 times 6. Well, we've got a 2 on the top, a 2 on the bottom, so those can cancel, and I'd be left with 5/6. So that's the gist, that's kind of the foundation of what we're doing for all of this unit. We're still just simplifying fractions. They're just going to look a little bit different than what we're used to. Okay, on this specific example, 328, we know how to do this. We've worked with a monomial on top and a monomial on bottom. We've worked with our exponent rules. Our exponent rules for division say that we just divide our numbers, divide our coefficients. 15 divided by 25 is going to simplify to be, let's see, they can both be divided by 5. So we're going to get 3 on top, 5 on bottom. And then our quotient rule says that we subtract our exponents. So we have 4 minus 2 is x squared. For our y's, we have y squared divided by y to the 6. So 2 minus 6 is y to the negative 4th. So I'm going to go ahead and move that to the bottom, and it becomes a positive 4th. So if we see a rational expression that is just a monomial, it's not something like this. It doesn't have a plus or minus in it. If we just see a monomial, we just treat it like problems we've seen in the past. But a lot of our rational expressions isn't just going to have one term in the top and bottom. It might have a polynomial or a binomial or a trinomial. So if that's the case, what we're going to have to do is we're going to have to first factor the numerator and denominator. Here's another time that factoring comes into play. So I'm going to jot down here, I'm going to put a little star. When we are simplifying rational expressions where we have more than one term in the top or bottom, we're going to factor first, then simplify. And I'm going to write one more thing here, and I'll explain it in just a second. So I'm going to write you can cancel factors, not terms. And I'll explain the difference. You can cancel factors, not terms. Okay, so 329, if we factor this, well, our numerator really we can't do anything with. There's just a 28 there. So we're going to leave that alone. Our denominator, we always look for a GCF first. It has a greatest common factor of 8. So I'm going to end up with x squared minus 2. Okay, now we do see what we can simplify. We've got a 28 and an 8 here. We can divide both of those by 4. We're going to get 7 on top, 2 on bottom. So we end up with 7 divided by 2 times x squared minus 2. There's no other factors on top and bottom that they have in common, so we can't cancel anything else out. So this is our final answer. And you do not need to re-multiply out the denominator here. You can leave it written just like that. Okay, for example 330, we have, on top we can take out a 3. If I take out a 3, I'm left with 3x minus 1. On bottom here, I can take out a 6, and I'm left with 3x minus 1. Well, look here, we have a 3x minus 1 on top, a 3x minus 1 on bottom. We have a matching binomial factor on top and bottom. So those cancel, and I'm just left with 3/6. Well, we know that 3/6 can continue to simplify, and we get 1/2. So when we talk about canceling out factors, not term, factors are things that are being multiplied together. Terms are things that are being added or subtracted together. And we'll see that. I'll give you another example on the next page of things that we cannot cancel out. We can only cancel factors, not terms. Okay, so flipping to example 331, we've got a binomial on top and a trinomial on bottom. So hopefully we're feeling more comfortable with factoring here. X squared minus 25 is the difference of squares. I can factor this to be x plus 5, x minus 5. On bottom, we have x squared plus 8x plus 15, two numbers that multiply to be 15, add to be 8, x plus 5, x plus 3. Okay, so here's one thing a lot of students want to do. They look at our original problem and they say, hey, look, We have an x squared on top and x squared on bottom. I'm going to just cancel those things out. That's what I was talking about. Those are terms, not factors. Those are things that are being added or subtracted together, not multiplied together. So we cannot do that. We've got to factor first, then see if we have any common factors. We have an x plus 5 here, an x plus 5 here, so those cancel. So I'm left with x minus 5 divided by x plus 3. And we have to stop here. A lot of times students are tempted again to say, ooh, I've got an x on top and x on bottom. I want to cancel those. Well, those are terms, not factors. So I'm going to put a little arrow here. I'm going to put a little star. We cannot cancel the x's because they're terms, not factors. They're terms, not factors. And let me just kind of give you an example, like with fractions you're used to seeing, that might make it make a little more sense. So let's think of the fractions. Let me just make them up. Let's see. We're going to do 4/6. Okay, if I want to simplify this, I could think of 4 as 2 times 2. I could think of 6 as 2 times 3. All right, well, 2 on top, 2 on bottom will cancel, so this really is equivalent to 2/3. So notice here we canceled factors, not terms. Let me show you what this looks like if we try to cancel some terms. All right, so if I have 4/6, I could rewrite 4 as 2 plus 2. I could rewrite 6 as 2 plus 4. Okay, so if we try to cancel terms, here's what happens. 2 and the 2, we're going to try to cancel those out. Well, that says we have a 2 and a 4 left, which simplifies to be 1/2. Well, 4/6 is obviously not equivalent to 1/2. So factoring out terms and canceling out terms and not factors is mathematically incorrect. We cannot do that. We can only cancel things that are multiplied together, not things that are added or subtracted together.